In some of our previous examples, we completed the square, and we knew from completing the square what the vertex and the axis of symmetry might be. There are times where we don't really need to do the full completing the square. We don't want to do the full completing the square. Our goal is not to write this in vertex form. Instead, all we really want is the vertex, and once we have the vertex, the axis of symmetry. So there's a couple of quick formulas, if we want to call them that we can get to get the vertex and then eventually the axis of symmetry. If I'm looking for the vertex, the x-coordinate, the first coordinate of the vertex, will always be given by negative b divided by 2a. So the x-coordinate will always be x equals negative b over 2a, which coincidentally will also give us exactly the formula for the axis of symmetry. So not only does x equals negative b over 2a give us the x-coordinate of the vertex, it directly gives us our axis of symmetry. Some of you may have learned a formula for the y-coordinate of the vertex, and it's a rather lengthy formula. I prefer not to use that formula, and I just prefer to say, if I want to get the y-coordinate, all I need to do is substitute in the x-coordinate, that negative b over 2a, into the function, and what I get as the output is the y. That seems to be a whole lot easier than trying to remember a second formula. Again, as I said, the axis of symmetry is directly the same formula, the same process as finding the x-coordinate of the vertex. The axis of symmetry is x equals negative b over 2a. Well, let's take a look at an example. Suppose I'd like to find the vertex and the axis of symmetry of the function f at x is 2x squared plus 3x minus 15. This particular problem would be a bear if I wanted to complete the square. I'd have all kinds of fractions. It just would not be pleasant to do. So let's just find the vertex using our formula. So we use x equals negative b divided by 2a. And so our b in this example is 3. So negative b would be negative 3. And I just happen to put the negative in the front of the fraction this time. But it gives me negative 3 divided by 2a. A is 2, so that's 2 times 2. So I end up getting negative 3/4. So the x-coordinate of the vertex is negative 3/4. We also now know that the axis of symmetry is x equals negative 3/4. Now to get the y-coordinate, we just compute f at negative 3/4. So we'll take 2 times negative 3/4 squared plus 3 multiplied by negative 3/4 minus 15. And if I do the math out, that gives me negative 129 divided by 8, which does divide out evenly as a decimal. It would actually give me negative 16.125. So in either form, whether I want to write this as a decimal or as a fraction, both are exact values. And so that would be acceptable either way. And of course, the axis of symmetry would be x equals negative 3/4.